Hello. So here's the thing. I've been trying to Here's the thing. I've been trying to fix the performance of my AWS Lambda that collects feedback from people clicking thumbs up or thumbs down on my emails, my blogs, book chapters, everything. Basically, everything is connected to the same system. And one of the problems I have is that because the query to save your vote is pretty slow, the Lambda to save your vote is pretty slow, I feel like I get a lot of dropped votes, things that just aren't coming through because people don't wait long enough on the page for the vote to load. Moving the voting to the backend, so it happens on demand when you're actually rendering the page, like using Remix or Next.js or something like that, also didn't work because then it just made the whole page slow. So that sucked. I tried converting it to Cloudflare workers. That didn't look as promising as I was hoping. So last night I had an idea. What if the problem isn't that I'm running this on AWS Lambda or cold starts or any of that? What if it's just that I'm an idiot? So that's what we're going to try to figure out today. We're going to look into whether I did a really stupid mistake when writing this code and try to fix it. So let's see. I'm going to minimize this now and stop. Yes, my girlfriend says I'm pretty stupid. So to set up the test, we're going to switch the project back to master. Git checkout master, git checkout -b, stop being an idiot is going to be the branch name. And we're going to look at, should I start this locally? So I'm not going to start it locally. We're going to instead go into, I'm going to show you what is the actual thing that happens. So we take the test lambda that I have, the one that runs in dev mode, load up the GraphQL, and we're going to get a widget, let's say this one, and then we're going to write a vote query so that we can see how fast it actually is. And then we're going to compare this speed with the improvements that we make in the next 30 minutes. I don't think it's going to take much longer than that. So we have this query. Oh, come on. And the query is going, oh no, it needs to be a mutation, sorry. So we have a mutation that is sending, what is it sending? Let's see. We have widget vote and we need the user ID. So let's grab this one. This is my test for live streams. So we're going to say live stream and we're going to say widget ID for also the live stream. I forget why this is made to be such a stupid API, but that's what it is. So we have widget vote, and then what else do we need? We need to pass in, I guess we can look at the docs. If we look at not save widget, but widget vote, that's what submits the thumbs up or thumbs down vote. We're gonna say, so user ID, widget ID is mandatory, and then we're going to say it's a thumbs up true. And we're gonna get back, what do we get back as a vote result? Hey fuzzy buddy, how are you doing today? Yeah, my girlfriend said you're definitely going to show up and she asked me to say hi. Let's see, the vote result gets follow-up questions, and let's say we want the vote ID just so we can see what's going on. And now we're gonna open the network tab, and this is, the Lambda is right now warm. So when we press play, we are hitting a warm Lambda and saving the vote, and the whole thing took about 400 milliseconds. Now 400 milliseconds doesn't sound like that much time, but when it's something that happens in the background while you load the page, and a lot of people are most likely not that interested in sticking around and they're not even really sure that something's going on, oh, excuse me, then 400 milliseconds is a long time. Now, what is this mutation doing when you are voting? So we're going to go into mutations, and there's going to be a mutation here called widget vote. That's the first thing that happens. First, we make your vote, and then the UI updates your vote with follow-up answers to follow-up questions. So the widget vote is, I think, doing something stupid here. You see how we are creating the vote ID using UUID. That's fine. It's not that slow. It's not the fastest thing in the world, but it's also not that slow. We're getting the current time and we're deciding what the vote type is. Pretty simple. Now here's where it gets tricky. We save the vote into, or rather, we update widget counts. So if we run a query as well, so let's run a query to get the widget. So we're gonna get the same widget we just voted on. Come on. Okay. Also, please let me know if my stream is lagging in any way, because I'm trying something new that might make things go smoother. And if this goes smooth today, then I can keep live coding and having Sundays as my excuse to hack around while on stream. So we're gonna say thumbs up votes and thumbs down votes. So when I run that, if I press play, you see we get this widget has been voted up 6 times and voted down never. And if I rerun the mutation, no, I need to, so I'm gonna comment this out, rerun the mutation, we added a new vote. And now if we go back, it should tell us that there were 7 thumbs up and no thumbs down, right? Yes, so thumbs up 7. Now, the reason I think the way I built this is stupid is because we first update the count on the widget and then we save the feedback, which means we're talking to DynamoDB twice instead of just once. And I think that if we change this so that we're talking to DynamoDB, talking to the database only once, and then let a DynamoDB stream update the actual counts on the widget later using essentially, what's it called? Eventual consistency, then I think this will be instantly a lot faster. So that's what we're going to try to do. We're going to take all of this and we're going to just talk to, we're just going to talk to, what's it called? Wow, I am brain farting right now. We're just gonna save the actual feedback row in DynamoDB because I have 2 tables. One is for what you can vote on. The other is the actual feedbacks. So we're going to just save it in the feedbacks, and then we're going to make a, yeah, that's what we're gonna try. So first, I need to update the type so that we are not getting the widget back. We're only going to be returning the feedback. So I need to go into my schema. Where is that? In GraphQL TS. Schema vote result is going to be just the follow-up questions and the vote ID is what we're going to get back. So we're no longer going to get any info about the widget. So vote result is returning the vote ID, which the UI then uses to connect your follow-up answers. It gets the follow-up questions so that it can render the follow-up stuff. And when it was created, who the voter was and the instance of joy, because I forget why that seemed useful. So we've got that. I'm going to get status. Let's say get, we're just doing the backend right now. So let's cd to the backend and we say get status, get add dot, get commit -m. We say eliminate one DynamoDB update. And we're going to see if this makes it faster. If this makes it faster, we can then go on to build the eventual consistency part. So I'm going to say yarn deploy. I think that's going to work. This builds the TypeScript, packages it up using serverless framework, and updates my dev Lambda on actual AWS infrastructure. So now if this is going to work, maximum patching window seconds. Okay, I forget why that's complaining. So let's see. I hope this works. And we had 397 milliseconds, 326 milliseconds. And I think when we try again to run the mutation, it's going to be more in line with 150 milliseconds. We'll see. Come on. And yeah, I'm just gonna wait before moving on to the next step. Usually I like to splice these, but I'm not yet sure if it's worth it. Let's see. I wonder if this actually posted on the Twitter. Yep. All right. So we've got that. Variables resolver reports removing old services deprecation. Meh. Okay, I think that's fine. So now we're going to reload this page just to make sure we have the right stuff. And we can verify we got the right thing, because if we go to widget vote, we now get a different vote result. There's no longer any info about the widget itself. Oh, but we are gonna need the follow-up questions, aren't we? Okay, we'll see if we can deal with that later. So we go to the mutation, we say we want the vote ID, we want the follow-up questions, we want what else? Let's get the voter and the instance of joy just because. And now let's see if it's faster. Press play. Okay, 501 milliseconds. That doesn't seem like it was faster, but it's the first time we ever ran this. So let's try again. Clear, play, 300, play, 280, 330, 146, 260, 280, 145, 132. So it doesn't seem like it's much faster than it was before. That's weird. That means my theory was kind of wrong. I guess I'm gonna need to, maybe I need to write a better actual test for this. Yeah, and it's also not getting the follow-up questions. Why is that? So let's go back here. And then actually, how do I do this? I'm going to, so we're testing this kind of lazily. I'm sure there are actual frameworks we can use, but let's see. With one DynamoDB query, we have 312, 288, 235, 146, 262, 282. Yeah, I know this is not very, there's better ways of doing this. 266, 319, and 280, 287, 267, 269. So it seems to go around 276 to 86. All right. How many did they get? Like 15? All right. So now we're gonna go back to two DynamoDB queries. Right. One DynamoDB, right. So now let's go back to the same thing and return the widget data. So GraphQL TS, Command Z, Command Z, Command Z, Command Z. And now I'm going to yarn deploy this, and we're going to try again. Basically the same test as we just did, just to see if there is any performance impact, or if I'm completely off base with what's making this slow. I'm also really open to suggestions in the chat room. Those are always great. Curious, how long does generating the UUID take? I wonder if that's actually slow. Let's see. UUID v4 performance. Complete guide to UUID versions. But bad for performance concerns. Okay, so UUID v4 should be pretty fast. Let's see, what do the benchmarks say? Jump to the latest result. UUID v4 can execute 722,000 times per second. So that is definitely not the problem here. All right, so reload the page again. Okay, now let's go. Play. So this time we got 200 milliseconds, 154, 169, 182. So I'm just pressing it a couple times. It seems to be kind of all over the place. It's not great. So let's see. So with 2 DynamoDB writes, we have 213, 154, 169, 182, 160, 292, 184, 308, 311, 151, 316. 316, 282, 379. I just realized I should have been writing this in a spreadsheet. So let's see. With 1 DynamoDB write, we have, what do we say? Let's see. Calculate average calculator. Otherwise, I'm going to open. All right, more spam. Great. Hey, David. My GraphQL server is it's an Apollo GraphQL server running on AWS Lambda directly. Let's see if this works. So that's 258 average. And with 2 DynamoDB writes, this is not going to make any sense, I think. It's 253 average. Neat. Okay, so that's not the problem at all. But yeah, David, the basic setup is that I have a GraphQL Lambda that just creates an Apollo server and creates a handler and runs that. So I'm using Apollo server Lambda, probably an old version. I wonder if Apollo server Lambda. Let's see if there is a newer version of that. Apollo server Lambda. So there is a new version. Instead of 2.5, we have 3.6. Honestly, I'm not that familiar with the internals of Apollo either. I think that yeah, I honestly don't know. I was hoping it's only doing it once, but you're right, that could be slowing things down. So let's try just updating. Git status, git add dot, git commit -m. Git commit -m. DynamoDB isn't the slow part. So that's weird. So let's try just upgrading it. Yarn upgrade interactive. And let's see. So we have client DynamoDB. That's fine. We can upgrade that. Client secrets manager. We can also update that. AWS SDK types. Yep. Util DynamoDB also fine. Slack webhook. Sure. Types GraphQL. Okay. Types UUID. Sure. Now Apollo server. Apollo server Lambda. Why is... Okay, let's just upgrade everything for now, doing the minors. So we update all of the minor versions first. And then I'm going to... I forget, how do we... What? Uh-huh. Okay. Package source code dependencies, deploy the API. Yes, yes, yes. Okay. So git status, git add dot, git commit minus m upgrade minors. Now, how do I upgrade interactive? How do I upgrade further than that? Okay, so let's try. Go to package.json and we have GraphQL. What is the latest GraphQL version? npm.js, GraphQL, published 16.2. Okay. Does anyone know a convenient yarn command to upgrade major versions? Because I always forget that. Okay, let's do yarn upgrade major. So if I say yarn upgrade Apollo server Lambda, what happens? That did not install the latest one, did it? Nope. So I'm going to just update the version here. So we say 3.6.1. How much RAM do the functions have? That is a good question. I think they have the default. Yeah, I did not set anything up for how much RAM they have. Good question. I will try to tweak that, but let's try upgrading it first and just seeing if new Apollo server stuff is faster. Git grab Apollo server. Where am I using that? Am I using it anywhere in code? Okay, I'll try that, but I want to try. I want to try this first. Remove Apollo server. And then Apollo, the other Apollo server. So we don't need. Don't save. Package.json. Did you remove here Apollo server Lambda? Okay. AWS SDK, GraphQL, we can upgrade to, what was it, 16 something? I'm really curious if this is going to just work if I upgrade it. So 16.2, 16.2.0, and Apollo server Lambda goes up to 361. So we say 361. And we need types GraphQL. Let's go with 16.2.0. So run yarn. Let's see if that upgrades. Types GraphQL, sure, 14.5. Okay. So we need to update this to 14.5. Okay, so I've upgraded the actual Apollo server Lambda. And now I'm hoping it's going to just work. I think one thing I need to change is in GraphQL TS. Now here we have Apollo server, GQL, and then we have the queries and the mutations. We now have to import Apollo server plugin landing page GraphQL playground from Apollo server core. Core. We need to add that yarn add Apollo server core, right? Provide resolver functions for your schema fields. Introspection is true. So this is where we create the handler. New Apollo server type devs, resolvers, and we need to add the plugin. By default, the GraphQL plugin interface and GraphQL introspection is disabled in production. If you'd like to have graphical playground and introspection enabled in production, install the playground plugin and set the okay, so it looks like we don't actually need this. So I'm going to comment it out for now. Yarn remove Apollo server core. And then I guess we, so how do I add cores in the new stuff? Response enable cores. We need that. There we go. So that's another change I need to make. Course now becomes express get middleware options, like that. Cool. So now I'm gonna deploy this, yarn deploy, and we'll see what happens. I'm hoping it's magically faster. And it looks like not using my iPad as a second screen with Sidecar is makes live coding go much better. But I can't see what you guys can see, so I have no idea what's going on. Maybe I do need to get a second monitor, but I hate having those. All right. So it's uploading the package. This is going, I hope this is going to dev. It should be going to dev. That's where it was going before. And then we're going to look at serverless framework memory config, because I always forget how to set the memory limits. It should be pretty easy. Memory size, yep. All right. Oh, it says that default is 1024 megs. So what am I actually setting it as? My account, AWS Management Console, Swizzets, sign in. Yes, whatever. We go to Lambda. So the Lambda for SparkJoy dev feedback dev GraphQL has 18 megs of code size. It should tell me how much memory it has here somewhere, shouldn't it? Info? No. Edit runtime settings? No. Monitor? Why do I always forget where the memory lives? Oh yeah, so it has so I think David that it has enough memory. It's set to 1024 by default. Okay. So now we reload this page. Ready to oh my god. What? Sure. What? Okay. This is new. Sure. Okay. I don't know why this is the way it is, but let's see. We had a mutation, or actually query, which gets the widget. Okay. So, sure. Now let's get all of them first. All widget. And we need the user ID. Oh, let me zoom this in a bit. We need the user ID and we need the widget ID so that we can see them. And then we're gonna set user ID and widget ID down here. So user ID, we're gonna keep the same widget as before, I think. Okay, like that. And then we comment this out and we say mutation, which is going to be widget vote, which gets the user ID and the widget ID, and it's going to need the thumbs up, which is going to say true. No? Okay, sure. Thumbs up Boolean, thumbs up true. Okay, let's see if this actually works. So play, syntax error, what? Oh, we need to get, let's say, follow-up questions and the vote ID, and let's say the voter, whatever. Play. So this is now running a bunch of stuff that I don't want it to, which is confusing, so I can't measure what we're actually doing. Let's try. Come on, what are you running all the time? Stop running introspection queries. It's so annoying. Like, does anyone know how to make this thing stop running introspection queries all the time? Because it's really messing up my ability to run a bunch of these. But let's see. So 427, 312, was it? No. Okay, let's go back to the normal URL we were using. Let's see what this does. Or query this graph directly. Ready to explore, get a free private query console and schema generated docs for your graph in Apollo Studio. Okay, querying my, right, so that's that. How do I tell it to stop running introspection queries? Because it really doesn't need to do that every 2 seconds. Okay. Well, either way, it doesn't look like it's any faster. So 566 milliseconds, there we go. 601, wow. So whatever Apollo GraphQL server is doing is pretty bad. With latest Apollo server Lambda. So let's go. Run 567. Wow, that is so bad. 575. 406. 503. 421. Wow. 416. Why is this so slow? 615. 443. Damn. Yeah, I don't know what this is doing or why is it so slow, but it's very slow. 662. Nice. So it looks like although it also doesn't look like the actual queries down here are that slow. So I don't know what this is reporting. Why is this saying 600 milliseconds where this is saying 415? All right, let's at least use the same measurement. So we're going to run this again. And then let's see if we can somehow filter by how this is running. So the payload introspection, track mutation, payload mutation. Can I filter these guys by the payload? Let's see. No. Does anyone know if I can filter requests by payload instead of by URL? That's one of the annoying things with, what's it called? One of the annoying things with GraphQL. No. No. Chrome DevTools filter network tab by payload. Pa-pam. No. I do not want to bookmark this. Remove payload. Nope. But so here's the thing though. Why would it be doing all of that if I'm using specifically the Lambda version of the server, which is kind of silly. But yeah, it does look like this is very slow. Cool. So that was interesting. And yeah, I still don't know how to filter this better. Polo server Lambda is very slow. Let's see if anyone. Yes, that's the official. Wouldn't this get memoized in the memory of in the Lambda's memory? No. Blah. Okay. This is so annoying. Cookies implementation. What? Cancel. Why won't this be less noisy? Query mutation, yes. Okay, that's fine. Yeah, I don't know how to make this less noisy. But basically, we're seeing that it's definitely slower than it was. So that's not a good sign. But at least it works with pretty minor changes. So I wonder if there's anything better than Apollo server Lambda. So David, do you have any recommendations for better GraphQL servers than Apollo for Lambda environments? Because this is pretty silly. I don't know what this is. What is this doing? Or is there any way to make it faster? Let's see. What does the README say? Or the documentation? Yeah. Okay. Apollo server Lambda. Type depth resolver, GraphQL handler. Okay, serverless. Configuring the underlying Express configuration. Well, that could be the problem. Why is it running all of Express for this? This Express is not made for Lambdas. So that could be the problem. I wonder if we can memoize the type defs. How does the GQL tag work? Fastify plus GraphQL, that's a good idea. Something to look into. So GQL comes from Apollo Server Core. So I wonder No, this probably isn't something I can memoize. Okay. Disable health check. Oh. What do you mean by cached variables? Because since all of this is in the body of the function, isn't it automatically cached between requests? I thought that's how Lambda worked. Because AWS Lambda cached variables. Oh, if server, that's new. I haven't seen that. Let's see. What? Interesting. I haven't seen that before. I thought it was automatic, or at least last I checked, it was automatic. It was automatically maintaining context. Oh yeah, I see what you mean. So we would go like this. Right. So we say export const server equals. So we need a essentially this. Actually, no. So we're gonna yeah, I know it's hard to write code, but I know what you mean. So I forget why is this being exported, but whatever. So we're gonna say, yeah, I don't think this needs to be exported, so I'm not gonna export it. I'm gonna say let server equals null, and then we say function get server for man's memoization. So get server is going to be if server, we return the server, else we say server, if there's no server, we say server equals new Apollo server with type defs and resolvers, and then we return the server. Oh, so it's, what does the Apollo server return? Apollo server or null, right? Okay, and then here we say get server, creates the handler. So that should make it so that we're not initializing the whole Apollo server every single time, which is a really good idea from David. I don't know why I didn't think of that before. For the type defs, let's do it this way. So I'm gonna say bam, type defs equals null, and we say function get type defs, which says if there's no type defs, we set them, and then we return type defs, right? Yes. Type defs equals blah for man's memoization, and this has implicitly an any type. So what does GQL return? It's a document node. Yep. So we say type defs are a document node or null. And we import document node from GraphQL. All right. And here we say type defs equals get type defs. which always returns the document node. All right. Yeah, I think you're right, David, that the GQL tag is doing a lot of work there. So we're now gonna try this. Status yarn deploy, and let's see what happens. Pretty exciting. This went in a completely different direction than what I was expecting when I started, which is a really good sign that I need to start doing this regularly and just having an hour every Sunday where I'm using live coding as an excuse to hack around with interesting stuff. Because I've been kind of missing that. Let's see. So it's checking, deploying, but will it actually deploy? That's the question. Da-da-da-dum. All right, so that deployed. Now I'm gonna reload this page. I don't know if that actually does anything, but I'm going to reload it. And now let's run this mutation and see, first of all, if it works. Okay, 590 milliseconds for the first one, or 356 as it says down here. Then we run it again. 694, 435, 494, 697, 277. There we go. 402, 433, 391. So that's a little better, but it's still not quite as good as I would like. However, down here, it's looking a lot better. So if we look at this one's probably going to be no introspection, mutation. So this one took 328 milliseconds. So that's better. We've definitely improved it a little bit with doing that. Not as much as I would have liked. Also, the amount of noise that App Apollo Studio creates is horrible. Let's see. Apollo Studio super noisy introspection queries. Yes. I just wanna. Yeah, I mean, honestly, in my lambdas usually I don't even like using anything like Express or any of that because I think it's too much overhead. Yeah, I don't think I want 3 gigs of memory on this, but let's give it a shot. Let's see what happens. Git add dot -a add memoization, git push origin, stop being an idiot, just in case. Let's try actually serverless, and we're gonna say this thing will have, how do we set memory? Let's do memory size 2048. Let's see what happens. Yarn deploy. Although it seems kind of silly to have that much memory for something so small. Yeah, I'll try something else. Plus memoization. So I think I was hoping that the latest version of Apollo Server Lambda would be faster. Turns out it's slower. So that was fun. Let's see. Come on. Yeah, I'm starting to agree with you, David. The Apollo and GraphQL are really nice. It solves a lot of problems, but it's just there's a lot going on in there. 639, 536, 541, 636. I don't think bumping up the memory did anything here. Maybe, no. No, it's just still slow. Yeah, not great. Cool. So that was fun. But we're basically at, where was I? What is track mutation? Why is it doing that? Yeah, so annoying thing with GraphQL is that everything is a post, and then this thing is making so many. Oh, so those are web. So at least I found an easy way to recognize them. Let's try. So we're gonna go with like, I don't know, I'm gonna press this 10 times. And then we're gonna look at the ones that have a small size. Those are our mutation queries. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, do you think API Gateway v2 is going to be much faster? So we have 335, 298. Oh, was this also us? Yeah. 79, 371, 145. Wow, this is like just all over the place. 363, 157, 261, 174, 313, and that's it. Really? Let's do a couple more. Huh. Well, luckily I don't really need to rate limit or any of that. Do you know why it's faster? Because I find that surprising. 309, 177, 166. So let's see. Now our average is average calculator. We come down to 249 milliseconds on average. So we had 258, 253, and 249, which means most of our time is being spent in GraphQL overhead, which isn't that great. Or actually, maybe not even in GraphQL overhead. It might just be... okay. So API Gateway v2 is newer and does less than v1. Interesting. So I think that right now our test is not great because we're either hitting mostly overhead of the actual Apollo machinery, or we're hitting the overhead of talking to the Lambda and coming back. So we can check that if we go to see the actual execution environment, or the execution, I forget what I was going to say. Here, we're going to go to monitor. First, let's see, did this work? Yeah, 2048. And if we go to monitor, we should be able to see duration. So the duration here seems to be in like, yeah. So it looks like we're spending about, on average, what is this? Yeah, it looks like we're spending about 100 milliseconds, which is kind of a lot, just on the round trip to US East 1 and back. And then the overall time comes out to like 250 milliseconds. But if you look at the actual execution of the Lambda, it's around 100 milliseconds, which means that the slowest part is actually the round trip time, not so much the stuff we were optimizing. So that was fun. Let's see if this does my shortcut work. Nope, shortcut died. So that was interesting. We figured out that I wasn't quite as dumb as I thought I was. I was dumb in a different way. Thanks to David Wells for helping out and giving me the idea of memoization. I might try API Gateway v2 some other time, but it looks like the slowest part of this Lambda is actually Apollo server and GraphQL because it's doing too much magic instead of being a simple request that you can just process. Ooh, 60% reduction in latency. That is a big reduction in latency. Okay. Maybe we should try that real quick. Damn it. All right. David, you got me. I'm going to drag this on a little bit. Let's just try it out. So if I go to serverless framework, gateway v2, it should be really easy to switch. API gateway, serverless framework, v2, HTTP API. Perfect. So we say HTTPI. So instead of HTTP, we say HTTP API. And that should be it. Right? I think so. Let's try. Yarn deploy. With API gateway v2. Now let's see. I'm really curious. If this makes a huge improvement, then I don't know. Value GraphQL does not satisfy pattern. Okay. So it needs to be /GraphQL. Now we try. Let's see. Because yeah, the Lambda itself was pretty fast at about 100 milliseconds. Now we'll see if we were actually spending that much time in overhead. Come on. Wow. That was fast. Yeah, I think you're right. I think course settings can be hoisted, but this is fine. I don't think it makes that big a difference right now. Checking stack update progress. So this might take deploy might take a little longer because it needs to set up a new API gateway. I wonder if it's going to give me a different. Oh, it should give me a different URL. Come on. Come on. Okay. Okay. So I think. Oh, interesting. It doesn't say /dev anymore. Now it's just /GraphQL. So we're gonna paste that here. Yep, that definitely changed. save, and let's see if that works. I need to log in to publish this graph. I don't want to publish this graph. Okay, let's see. /GraphQL, what happens? Query your server. Are you gonna work? Okay. I wonder why it's unable to reach the server now. Run. Access to fetch from origin has been blocked by course policy. Response to pre-flight. Weird. Yep. Set course in the provider. Course. Yeah, provider. So it's not so much that that course can be hoisted up to the provider, it's that it has to be. Oh, that's cool. All right, I'm gonna let the internal course return headers, and let's see if this works. Would actually be cool to move them here and always return the course header. Oh, come on. You can do it, computer. Unrecognized property course. That should have been my my clue, shouldn't it have? Pa-pa-pam. Come on. Come on, computer. Come on. Okay. This part is always kind of frustrating because you're just sitting there waiting. Okay, now let's try this again. So we go in here, paste, save. Let's reload the page just in case. There we go. So now when I run this, we get, wow, 315 milliseconds, and down here it's 208. Whoa, whoa, whoa. So let's go 208, run. Nice, this looks a lot better. Wow. Okay, I was not expecting that. Let's clear that. So let's just run it a couple times and get a new average. But that's pretty crazy. Yeah, that is consistently a lot faster. So now let's see, we have these ones, right? Wow. That was a really good tip, David. So 28, 163, 157, 148, 181, 174, 149. Wow. 149, 163. Wait, are these actually my test ones? Yep, they are. So let's say 179, okay, 178. I got lost. 75, 186. What's data loader? I don't think I've tried that. I don't know what that is. What do you mean by data loader? Wow. Okay, so now what is data loader? And that's, we're definitely gonna lead Salesforce data loader. I have a feeling that's not what you meant. GraphQL data loader, that seems more promising. Oh yeah. caching lib for GraphQL. Okay. So I don't know if the caching lib would really be that beneficial for writes, but I can see that being really helpful for reads. So we're gonna leave that for another time because this is already a huge improvement. Let's just switch this back down to a normal amount of memory. Cool. All right, so I think we made a lot of progress here. I'm gonna deploy this to actual production. Thanks again, David, for all of the tips. And it's really interesting that API Gateway v2 is so much faster than v1. So I had no idea, and today I learned something. So that's great. Thanks everyone for watching. I will see you again next Sunday when we are going to do some other exploration or hack. I don't know yet what it's going to be. Bye.